Get ready for a spectacular planetary event on an unprecedented scale. Betelgeuse, the red giant star at the edge of our galaxy, is sending ominous signals across the universe. Using the James Webb Space Telescope, astronomers have discovered something very disturbing about this massive celestial body. Renowned astrophysicist Brian Cox has issued an ominous warning, addressing the big question. Are we about to experience a catastrophic supernova explosion that will change the night sky forever? Let's take a look at this situation. In the vastness of the universe, where stars are born, live and die in spectacular displays, recently a star has attracted the attention and concern of astronomers and the public. This star is Betelgeuse, a large and massive red giant in the constellation Orion. Its distinctive red color and unusual brightness have long fascinated observers, but recent developments have increased interest in this celestial monster. As we explore the shape of Betelgeuse, we are approaching a famous event in its life cycle. What do these changes in Betelgeuse indicate? Can we see the beginning of a global revolution of unimaginable magnitude? Betelgeuse, 764 times the mass of our Sun, is a star. His greatness is beyond comprehension. Imagine a star so massive as to replace our Sun, its surface extending beyond the orbit of Mars to include Mercury, Venus, Earth, and Mars. This large size is not only indicative of Betelgeuse's physical properties, but also indicative of its place in the stellar life cycle. Betelgeuse is extremely massive and is in the twilight of its life, a phase characterized by expansion and cooling after a lifetime of fusing hydrogen into helium. Betelgeuse, estimated to be 8 to 8.5 million years old, looks young to humans but is ancient in terms of stellar life. Its current red phase is the culmination of millions of years of stellar evolution marked by major changes and processes that transformed it from a hot blue star to the red giant we see today. The life cycle of stars like Betelgeuse is a story of transformation due to intense nuclear fusion and gravity. Betelgeuse's red color is a characteristic of its current phase. The red color is due to the cold surface of the surface compared to stars like our Sun. While the surface temperature of the Sun is around 5,500 K, Betelgeuse's cooler surface registers around 3,500 K, allowing it to emit light at wavelengths that give it its reddish appearance. This color is not just a visual image, an overview of the physical state of a star and the processes that take place in the atmosphere. Its previous color change adds to the mystery of Betelgeuse. According to Roman and Chinese records around 2,000 years ago, Betelgeuse appeared yellow. Until the 9th century, Arab scholars called it red. This color change throughout human history is not only a story of the planet's history, but also an indication of the star's evolutionary path. Betelgeuse's variable brightness is another remarkable phenomenon. It is a variable star, meaning its light changes and fades, a dance of brightness that has fascinated astronomers and skywatchers for centuries. In fact, Betelgeuse has a 400-day cycle with a long cycle of 5 years. These cycles have been documented as far back as 1836 by Sir John Herschel and possibly even earlier in Aboriginal oral traditions. What makes Betelgeuse truly enigmatic is not just its changing brightness but also its irregularity. Unlike many stars that follow a predictable pattern, Betelgeuse occasionally deviates from its rhythmic dimming and brightening, hinting at complex and less understood processes occurring within its colossal form. And a recent groundbreaking revelation, Betelgeuse captured the attention of astronomers and stargazers worldwide with an unexpected and dramatic change in its appearance, now famously known as the Great Dimming. In late 2019, Betelgeuse, one of the brightest stars in the night sky, began to dim mysteriously. This dimming was so notable that it started losing its brightness at an average rate of 0.01 magnitudes per day, reaching its lowest point in February 2020. Betelgeuse, which is visible to the naked eye, becomes fainter even in areas where the light is polluted, a change that can be seen by astronomers. However, monitoring Betelgeuse's activity is a challenge due to its periodic nature. When we look at a star like Betelgeuse, we don't see it as it is now, but as it was before, when the light reaches us. For Betelgeuse, about 725 light-years away, the moon we see today left the star about 700 years ago. This delay makes it difficult to predict and monitor sudden changes in the star's behavior, because we are looking at the past. The faint Betelgeuse event demonstrated the difficulties of real-time astronomical observations and the limits of our understanding when dealing with large global scales and seasonal variations. They send it. This celestial drama was closely observed by Andrea Dupree, Associate Director of the Center for Astrophysics at Harvard and the Smithsonian, and his team. They used the Hubble Space Telescope to study the giant star as part of a 3-year study of changes in the outer atmosphere. These observations provide unique insight into the dynamics of a variable star like Betelgeuse, which expands and contracts, causing changes in brightness. By analyzing the Hubble spectrum, the researchers measured the movement of material in Betelgeuse's outer atmosphere, focusing on magnesium-2 lines that indicate the star's atmospheric conditions. The observations showed that the object was moving from the surface of the star into the outer atmosphere at a speed of 200,000 miles per hour. Eventually, this hot and dense material spreads millions of miles from Betelgeuse, leading to the dust cloud that dims the star. Dupree and his team estimated that about twice as much material from Betelgeuse's southern hemisphere was lost in the 3 months after the explosion. This loss of mass is significant, especially considering that Betelgeuse, like all stars, is still losing mass, even at a faster rate than our Sun. The scale of this mass ejection and the subsequent decline of the Moon led to debate among astronomers as to whether the event could have led to a supernova explosion. Betelgeuse's proximity, about 725 light-months from Earth, adds to the intrigue, as all explosions are visible from Earth, a rare opportunity to see one. Near supernova. However, the question remains, what does this faint event mean for Betelgeuse's future? Is this a sign of an impending supernova or just a unique episode in a star's long and complicated life? Several theories have been proposed to explain this sudden change. A popular theory suggests that this is a stage in the supernova explosion process, attracting attention because Betelgeuse is nearing the end of its life. Another popular theory is that dust, possibly from the star itself, is obscuring our view. A third explanation for the changes in a star's photo is that it considers the visible surface layer, which affects its brightness. In-depth research using different visual techniques helped unravel this mystery. Spectroscopic studies show a decrease in Betelgeuse's effective temperature, suggesting that it may be due to the darkening of the star's surface. This theory was confirmed by the observation that Betelgeuse's temperature dropped by at least 170 K around the ecliptic, indicating significant surface changes. Finally, the key to understanding this strange phenomenon came from the observations of the Hubble Space Telescope. They said that Betelgeuse's appearance is that Betelgeuse's descent is caused by a large amount of hot material being ejected into space, creating a dust cloud that covers part of the star's surface. The object, believed to have exploded from a large convective cell on the star's surface, cooled as it moved through Betelgeuse's atmosphere, forming a cloud that obscured the light from a quarter of the star's surface. The observations recorded evidence of hot and dense material moving through the star's atmosphere months before the eclipse. Ground-based telescopes also recorded a decrease in the star's brightness, particularly in its southern hemisphere. As the material cooled, it formed a cloud of dust that covered part of the star and darkened it. What does the massive outflow of material mean for Betelgeuse and supernova theories in general? The implications are profound. According to traditional understandings, the red mass like Betelgeuse will be reduced before the end of the explosion. However, the extent of this expulsion challenges this view, suggesting a more chaotic, perhaps unimaginable state of affairs for these stars. Is Betelgeuse preparing for its doomsday? A supernova explosion in the next few thousand years? Recent studies have speculated on when such an event might occur, suggesting it could happen sooner than previously thought, possibly within the next couple of years. Meanwhile, while Betelgeuse is undergoing these major changes, another cosmic event is attracting attention: the supernova SN 2023 IXF in the Pinwheel Galaxy. This spectacular explosion, seen in May 2023, provides comparative clarity and reminds us of the explosive power of stars like Betelgeuse. Will we see a similar phenomenon for Betelgeuse? Only time will tell.